Hello, I'm John Wallace, Senior Editor at Laser Focus World, and welcome to today's quick chat where we talk with an experienced person in the area of optics and photonics who will discuss practical knowledge for our audience to use as a guide for their own R&D efforts, either commercial or academic. This is the second of two interviews with Christopher Boucher, Technical Product Manager at COMSOL, a company that produces simulation software with numerous uses in optics and photonics. This second interview will get into some examples of what COMSOL's software can do in optics and photonics. Welcome again, Chris.
Hey, thanks, John.
So as I've been mentioning, COMSOL software is especially interesting because it doesn't model just optics. It models other things too. So I'd like you, could you discuss that for a bit? And then I have some more specific questions.
Absolutely. So first off, COMSOL has two major classes of method for doing optical simulation. There are the methods where the object is much larger compared to the electromagnetic wavelength. And there are also methods that are more useful when the object and the wavelength are about the same size. So when the object's optically large, we're usually looking at ray optics. When the object is optically small, then you're usually looking at something based on the finite element method, which is a very common and well-established numerical method for solving for fields. And in this case, more often than not, it's an electric field. But you can also solve for other kinds of field. Now, the first things that you'll usually introduce would be structural deformation and temperature. So when you combine structural deformation, temperature, and optics, then we call this structural thermal optical performance, or STOP analysis in the case of ray tracing. Now, an interesting thing here is that we're solving for the displacement and the temperature using the finite element method, but we can even combine it with ray tracing. So we're not actually just combining different physics, we're combining fundamentally different methods inside the same software. Now, if you want to extend this even further, let's consider an object is heating up. You're interested in the optics of, say, a heated lens system. Now you also want to cool this off with something like forced or natural convection. You have the choice of extending your analysis even further by including a fluid flow or CFD calculation, and then you can more accurately model the convective cooling off of your optics. So we start out with just optics, then we can extend to heat transfer and structural analysis, and eventually this could extend to even include fluid flow. Other things that you might consider adding would be, I think there are some applications with chemistry, things like electrophoretic graded index lenses would be one example. MEMS, we can do piezoelectricity, so you might have some piezoelectric elements in your system. Really, almost any kind of physics in COMSOL can combine with almost any other physics. So the sky's the limit.
So I was actually right when I mentioned chemistry. Okay. Also, the COMSOL simulation works at multiple scales. So what about different scales? Optical simulation at different scales. How does that work?
So this is something that we've been looking into for the past year or so, this idea of multiscale modeling with, in electromagnetics. So I predominantly work with the ray optics, but I've also been doing a couple of models using the frequency domain tools with this finite element method. So here are a couple of examples of the kinds of things that we're looking into. If you have something that is radiating out waves, so one example of this might be something like an antenna, then you can perform this type of calculation called a far field calculation, in which you have the space immediately around your antenna. You're solving this with the finite element method, and you do this transformation to get the electric field at an arbitrarily far distance away from the antenna, sort of its asymptotic limit. So In our last release, version 5.5 that came out last fall, we included this feature that allowed you to launch rays picking up the electric field from this far field radiation pattern. Now, the way that this works is that each ray that we're releasing can include polarization information along it. So we actually store Stokes parameters on the rays. So you can solve for the far field radiation pattern, launch rays, and they get the intensity and polarization from that pattern. You can think about it kind of like a submodel. You can solve for a really, really small thing, and then you can use a separate method to trace rays in the big thing around it. Another example is analyzing a diffraction grating. You might model a single unit cell, a single groove of this grating to get the transmission and reflection coefficients for the different diffraction orders. And you can actually feed that information into a ray tracing calculation. And then that diffraction grating just becomes a boundary somewhere in your design. So you can trace rays as they go very long distances and then hit that grating. So these are just a couple of examples of the kind of multi-scale models that we're looking at, combining optically very large and optically rather small entities by using different methods together.
Mm-hmm. I know from attending past COMSOL conferences that you have other tools available. I remember one called the Application Builder, I think. I wonder, how do all these enable you? I mean, can you automate the setup of optical simulations? I mean, is that possible?
So there are different levels of automation, and it basically relates to your comfort level with the software. So at a very fundamental level, you can think of automation as something like a parametric sweep. Now, this is a tool built into the software where you can set up an analysis and then make that analysis automatically run as you change the value of some sort of input parameter. So for example, if you're doing a stop analysis and you have a heat source, then you can run the same simulation for 100 or 1,000 different values of this heat source. And you could just, one click, walk away, you go back later and you have your data for this 1,000 different runs. Now, if you're looking at more in-depth automation, setting up your model, then you can use these tools that we call the Application Builder. And to go along with that, there are these tools called form and method editors. Now, what these allow you to do is create a custom user interface and then run the model through that customized interface. So if you have a very big, complicated model, you could say, I want the user to be able to change this parameter, this one, and this one. You put those into your interface, and then that is what the application user would see rather than the model that's underneath it. These methods that I mentioned are bits of code that you can execute while you're running the model. So you can actually write code to set up your boundary conditions or your geometry as an alternative to just constructing it all manually. Now, this is a little bit more advanced, but once you start to get comfortable with the software, then I think that you'll find if you're working on a very sophisticated model and you want to change very specific things about it, then turning it into an application is actually a great way to not only speed up your own work, but also share your work with other people in your organization.
I'm interested in the leading edge, what's happening at COMSOL now. What are some areas where COMSOL is making progress? What are the newest things going on and that kind of thing?
Well, in terms of using the software in general, then one pretty recent thing that we introduced is called the COMSOL compiler. And this is when you create these specialized applications, these custom user interfaces, you can use this tool called the COMSOL compiler to turn your application into a standalone executable. And you can actually then freely distribute these executables in any way that you see fit. So it's almost like you're using COMSOL to spawn off your own simulating program, and that program is being powered by COMSOL under the hood. And then you can pass those out to your coworkers and colleagues and so on. So this is sort of in the general area of how to use the software better. Now, if we're looking specifically at optics, then some of the things that I've been working a lot with are this multiscale modeling that I mentioned, and also this structural thermal optical performance or stop analysis. These are some of the more in-depth multi-physics models that we've been working on. In addition to that, simply making the tool perform better. We try to make every single version more usable, faster, more robust, more responsive, and more user-friendly than the version before. We're introducing more specialized post-processing tools. So in the last version, for example, we made it probably 10 times easier to create spot diagrams than it was before. And another thing is that we really listen to our users. So when users write in, they have questions about how do I make such and such a plot, then we really listen and we look for the best way to make that easier for them in the next release.
This last question is one I asked in the first quick chat, but it bears repeating. What kinds of resources do people have to learn more about COMSOL?
A number of
and I know about some of them personally because I've been to the COMSOL conferences and they're great. So I recommend them. And anyway, go ahead.
Oh yeah, John's been to a couple of the conferences. We have a lot of great, at our conferences every year, we have a lot of great mini courses. You can listen to COMSOL experts, including engineers and developers, speak on a variety of topics. There are user presentations that you can attend. There are poster sessions. Now, of course, this year, we're moving all of our COMSOL conferences to an online format. You can, if you're interested in signing up for a COMSOL conference, typically they're in the autumn each year. I think that the North America conference is first week of October this year. So that's worth checking out. For a lot of resources, you can look at our website, comsol.com. We have blog posts, user stories, video series. We have a number of example models complete with instructions that show you how to set them up step by step. And if you're really interested in trying out the software, then you can reach out to somebody at COMSOL and ask about trying it out for yourself.
Okay, well, that concludes our second quick chat. I'd like to thank our quick chat guest, Christopher Boucher of COMSOL, for providing us a look at COMSOL and its simulation software. On behalf of Laser Focus World and Endeavor Business Media, we thank you for joining us today, and please keep an eye out on our website for other quick chats.